Hello everyone, welcome to our channel. So as you know, we are going to solve problems from NCERT. So in this video, first I'm going to explain the first chapter, which is relations and functions. So first we will do the topics one by one, and then we will go to the exercises. Okay. So the first topic is in your book. Okay, before that, let's start with the what you have studied in your class 11th. So the topics are that you have studied already in class 11th. Those are relations. Over there you have done definitions and examples. And then the second one is functions. Then you have studied about domain and codomain, and you have already studied about range. Then one last topic was there in that first chapter, and that was a real valued function. Okay, so these are the topics that you have already studied. Now in this chapter we are going to study in more details about relations. So we will see types of relations. Okay, so let's take this types of relations. So first of all, you should know the definition of this relation, which is already given in my video, which is in class 11. Okay. So relations, like the term is, it is connection. Okay, connection, or you can say link between two objects or two elements. So you have to set a relation, a connection between two objects. Now it will be given, like sets are given, and you have to find the relation among the elements of those sets. So suppose you have two sets, like A is equal to set of all students in say class 12. Then you have B. So you have that, say again, set of all students in class 10th. Okay, and these two are from the same school. So you have to find a relation. Now we will define a relation between A and B. So how you are going to define this? It is written as A is related to B. Okay, the notation is you have to write A is related to B. If you have the elements, these are the elements from the set AB. Okay, so they are related if A is a brother of B. So students of class 12th and 10th are from the same school, and the relation is the element of A. Some student from this class A is related to some student of class B if A is a brother of B. So you have to find this as a relation. So this is one example of relation. Okay. Now let's see relations one by one. The first one, which is given in your textbook, is empty relation. So let's check what is empty relation. This empty relation, you can also write it as void relation. Void means it is empty. No element is there. Okay. So the name is empty relation or void relation. Now what this says, it is a relation R in a set A. It is called empty. Now when it is empty, when you say something is empty, when nothing is there inside that. Okay, so if no element of A is related to any element of A. Okay, so if you have a set A and no element of A related to itself, then it is said to be empty relation. Okay, again we can create one example for this empty relation. Now the notation for empty is R is equal to phi, which is a subset of A cross A. A cross A is the notation for relation. Okay. So suppose take one example. Suppose you have set of all A, take A capital A as set of all students in a boys school. Okay. Now A is a boys school, set of all students in a boys school. Now you have to set a relation R between the elements of the set A. A, B, these A, B are students. Okay. Such that A is a sister of B. So as you can see that set A is actually set of all students in a boys school. So all are boys in that school, and we set a relation AB between the students that A should be a sister of B. So it is not going to be possible. So that means this relation is going to be empty. So we cannot put any element in the set A cross A. So relation is empty. So that means R is equal to phi in this case. Okay. Now the second one is, okay, one more thing is there, that this relation is going to be the smallest relation. So that empty relation, this you should know, that empty relation is the smallest relation. So among all the relation that you find, this one is going to be the smallest relation. Okay. Now the second one is universal relation. Now as the name suggests, universal is, you can guess from the name, that universal that includes everything. Okay. So universal relation is a relation R in a set. Every time a relation is defined on some set, so it is defined in a set A, is called universal relation if each element of A is related to every element of A. Okay, so that is, you can write that R is actually the whole of A cross A, because every element in A is related to every element in A itself. So that means this R becomes the whole of A cross A. Okay, so let's understand this by one example. So if you have A, which is equal to set of all, again take the same set of all students, set of all students in a boys school, and we will take a relation R on the elements AB. That means these two are, small AB are students. Okay, these two students are related if say take the difference between heights of this A and B is less than 3 meters. Okay, now when you take the difference of any two boy, no matter how small or how tall the boys are, if you take the difference between two boys among the school, you will always get the height which is going to be less than 3 meters. Okay, so that means this relation includes everything. So this means it is going to be A cross A, and hence it is universal. Okay, and this universal relation is, as you saw, that empty relation is the smallest relation among all. Same way, this universal relation is the largest among all. So universal is the largest relation. Okay, so it is going to be the largest. So whenever you get a universal relation, that one is the largest. Okay, the next one is identity relation. Identity relation is, so again, as the name suggests, identity, so it is going to be the same. Okay, like if you have a relation as you can see in the mirror image, the reflection of yours, it is same. So identity is, you will get the relation between the same pairs. So what this says, it is a relation. So we denote this by I in a set capital A is identity if every element of A is related to itself. So what this means, so if you have a relation I and you want this relation to be identity, so in that case that A should be related to A itself. Element A should be related to A, B should be related to B, C should be related to C, like this you should have. Then this is going to be an identity relation. This is for all A that belongs to A. Okay. Now the main important topic in this chapter is the next three types of relations, and those are reflexive, symmetric, and transitive. So this you should know in details. The first one is reflexive relation. Now reflexive relation is again same as identity relation, and there is a little difference. So a relation is said to be reflexive if you have the pair AA that belongs to R. Always one set will be given, A will be given, and some relation will be given to you, and you have to check whether that relation is reflexive or not. So if you get this pair AA belongs to R, and this should be true for every A belongs to capital A. If this is true, that AA belongs to R for every A belongs to A, then the relation becomes reflexive. Okay. Now the second one is symmetric relation. So what is symmetric relation? Again, you will be given a set A on which the relation is defined, and some relation will be given, okay, with the definition. So if you have this condition that if A, B belongs to R, if you have a pair in the set R, okay, you have to look your R carefully. If you have a pair AB in R, then BA, if you reverse the order, that should also belongs to R. If this is true for all AB that belongs to A, then it is going to be symmetric relation. Now let's come to transitive. So in transitive, we have to consider, transitive means it will transfer. In this case, you have two pairs like AB belongs to R and BC belongs to R. So if you have AB belongs to R and BC belongs to R, that should implies that AC should be in R. Okay. And if this is true for all ABC, that is in A, then it is going to be transitive. Okay. So now if a relation which is reflexive, symmetric, and transitive, if a relation is reflexive, symmetric, as well as transitive, then this is known as, that relation is known as equivalence relation. So what you can say about equivalence relation? So a relation which is reflexive, symmetric, and transitive. Okay. So it should be all reflexive, symmetric, and transitive. Then it becomes an equivalence relation. Now we will do some examples based on this in our next video. Let's take a set R which is given by A comma A, B comma B, C comma C, and say AB is there. Okay. Now this is defined on a set A which is ABC. So what you can say about this relation? Is it going to be reflexive? Is it going to be identity relation, or both? Okay. So as you can see, for reflexive we want that each and every doublet the doublet should be in R. Okay, if you have your set A as ABC, that means AA, BB, CC should be in R. So in this case, as you can see that AA, BB and CC are in this capital R. So that means this is going to be reflexive because we have that AA belongs to R for all A that belongs to A. Now what about this identity? For identity, the definition is you should have that each and every element should be related to itself only. No other elements are allowed. Okay, so in this case when you see your R, it is AA, BB, CC, and we have a pair AB along with this. So this is extra one. Okay, we don't want this in our identity relation. So that means if AB belongs to R in case of identity, okay, so this is not allowed. So that means it is not an identity relation. Okay, in identity relation we need only AA, BB, CC, only this much. Okay, but in case of R we have to look that the doublet should be there. If anything else is there, we don't see that, but the doublet should be there. Okay, so this is the relation. So you can say that, so this may come in your MCQ, that identity relation, if a relation is identity, okay, that is going to be reflexive always. An identity relation is always a reflexive relation. But if you have a reflexive relation, that may not be identity. Okay, so this you should know.